Okay, so this is a quick video on how to draw a tangent to an ellipse from any point on the curve. Okay, so first thing I'm going to do is I'm going to pick any random point. So call this point P here. So random point on the curve works for any point that touches the outside of the ellipse. So a tangent then, lads, is a point on a curve, so for example a circle, that touches it at one single point. So you can see it touches it there. So the same thing for the ellipse, touches it here at one single point like that. Okay, so first thing you need to do is you need to find your focal points. So half the major axis from the top of the minor axis, give you your two focal points. Okay, so F1, F2. You're then going to need to join your focal points to your point on the curve and extend them beyond. Just like that. Extend them beyond P. So then you can see you have four angles. You have these two opposite each other and these two opposite each other. First thing we're going to do is we're going to draw our tangent in here. So if you have an idea, right, if you were to bisect this angle, which we're going to have to do to find the tangent, if you were to bisect this angle, it would run in this direction. It would cross the curve. We don't want it to cross the curve, we want it just to touch the curve. So if we either bisect this angle here or this angle, we can create a tangent to the curve. So to bisect an angle, then you open your compass out to a random distance, put the point of it on P, draw in a curve like that. Okay, so just color that in there. Again, a random curve, and using the same distance on your compass from the end of each end of that curve, you're going to draw a arc in like that. Okay, the two arcs will cross over each other. So just like that there. So those two arcs cross over each other at a singular point. That point is also a point on the tangent. So if we have point P on the tangent and we have this point, we can just join the two of them up and extend them, giving us a tangent to the ellipse at point P. Okay, so I'm just going to draw that in there. Just like that. Now, in certain questions they will talk about the normal of a tangent. So the normal of a tangent, lads, is perpendicular to the tangent at the point of contact. Okay, so there's two ways of finding that. The first and the simplest way is if you get the tangent using sliding set squares, you'd get a line perpendicular to the tangent at point P, like that. Okay, so using sliding set squares. Now they're not used correctly there, but you get the idea. The other way then is if you bisect this angle here or this angle here. So I'm just going to do it that way. So again, random distance from point P, I'm going to bisect this angle here like that. Point of your compass on here, draw an arc, point your compass on here, draw an arc. Now they didn't cross over each other, so you just go and extend it, giving you a point here, which is also on the bisector of the angle. Join point P then to that point. That there is your normal. And you have your tangent here then. Tangent. And that is how you get the normal and the tangent to an ellipse at any point on the curve.